Alright, I simulate things. It's kind of what I do. Unfortunately, creating simulations is kind of a niche topic. There aren't many tutorials or example projects you can find out there, if any, on how to do things. So I figured, why not do it myself? So this is going to be a tutorial series on how to create an ecosystem simulation in Unity. Alright, so let's just create a new Unity project. You can name yours whatever you want. I'm just going to name mine ecosystem tutorial. And once it's done loading, you should have something that looks something like this. Just going to rename the scene to simulation and create a few folders. And everything should look something like this. Alright, so for ecosystem simulations, there are basically four main principles: movement, resource consumption, reproduction, and evolution. Today we're just going to do some quick movement to get the basic foundation going. So, just create a new C# script. I'm going to call it animal. Open that up in Visual Studio. Now, at this point you might think we would use something like navmesh systems, but the thing about navmesh agents is that there are only a certain number that can exist at a time, and when you're just doing something simple like this, you don't really need that many navmesh agents. Especially for simulations, you want to be able to create millions of instances of creatures, and navmesh agents just aren't built for that. So instead we're going to create our own movement function. First, let's just create a vector3. Call it target position. And let's create a move function. This will take in a vector3 as a target position. Now, this move function is pretty simple. We just want the animal to move from one point to the next. Now, this is surprisingly easy with the way Unity sets up things. All you need to do is set the position equal to vector3 dot move towards. Now, we need to pass in our current position, so that'll be transform dot position, the target position, so that'll be our target position, and the speed. Now, currently, we don't have a speed value, so let's create one. Let's just set equal to 10. And here, we want to multiply it by time dot delta time. In the update function, I'm going to call move, pass in the target position. Great. But currently, the target position isn't really anything. We need to set it to something. You could keep it at the default value of the center of the world, or 0, 0, 0, but let's create a random position. So let's start. We're just going to say target position equals new vector3, and in here we want to get some random numbers for the x and the z positions. Nothing random for the y. So we're going to say random dot range, put it from 0 to 10. Set the y position to 1, and again random dot range 0, 10. Now this will change the position of our animal, but we also want it to look at where it's going. It's very simple. We just call transform dot look at our target position. Now, this works, but it might give some unwanted results. Think of it this way. Move towards a function gradually takes one point and moves it to another. So imagine we have two animals, one that's tall and one that's short. They both have separate y positions. So when the tall one is chasing the short one, if we pass it in the direct position of the short object, it's going to lower in the Y position. And we don't exactly want that. We want it to be always planted directly on the ground, never going down or never going up. A way to fix this is by creating a new vector 3. So we create a vector 3, call it target, set equal to a new vector 3. And here we're going to pass in the target position on the X, and then for the Y, we're going to put our current Y position, and of course the target position on the Z. Now we just need to use this variable. And great. Now what this will do is it will move us to the target point on the X and Z axis, but keep us planted on the Y. That way whatever we set the Y position to will continue to be the Y position, which is exactly what we want. And up here, we're just going to create a distance variable, set it equal to vector 3 dot distance, and this will just calculate the distance between 2 points. So all we want is to calculate the distance between our current position and our target position. Then we can check if the distance is less than or equal to 1. And if it is, we'll create a new random position. Great. So let's head back into Unity. Let the script compile. And I'm just going to create a quick scene here. So create a plane. Scale it up a bit. And then I'm just going to create a new cube. We're going to call this cube animal. And I'm going to give it the animal script. Let's move the animal up on the y-axis to about 0.5. Looks about right. We're just going to give it a nice green material. Now, if everything's correct, this should work. As you can see, we have the block moving back and forth at random. So this works and all, but as you can see, it only moves in this little range here, which we don't really want. We want it to move across our entire terrain. And that's where environment scripts come in. Now, an environment script we can basically think of as like a simulation manager. At the beginning, it spawns in all of the different animals we need to spawn. It gives us their population. And, the most important one right now, getting a random position on the map. So, this script is going to be very simple for now. Just create a new C# script. Call it environment. And in this script, right now, all we need is a range. So let's create a public float. We'll just call it range. And we don't want this to be too big. We also want to give it a slider. So let's give it a range from 10 to 1,000. Then let's create a nice public method here that returns a vector 3. We'll call it get random position. And this will just get a random position on the map. So all we really need here is a new vector 3. So we're going to return a new vector 3. Again, we're going to use that random range function. So random.range. And here we're going to input the negative range and the positive range. Then repeat the process. And there we go, a random position. But we also want to be able to tell how big our range is in comparison to our land. So we'll draw some debug gizmos in order to see it. So So void on draw gizmo. We'll set the color to blue. And then when called gizmos dot draw cube, and this needs a vector 3 for the center of the cube and a vector 3 for the size. We create a new vector 3, each access the range. Range, range, range. And that should do it. Save that, head back into Unity, and we're just going to create an empty game object here. Give it the environment script. Here we can see the range. So set the range to 10 here. And there it is, the cube. This cube is our range. So you can see if we increase it, the cube grows, but if we decrease it, the cube shrinks. So we want the range to cover the entirety of our land. So let's set it to something like this. How it seems to work. Now, in the animal script, we just need to call that getRandomPosition function. So first we need a reference to the environment. So environment. And here we'll set the environment equal to find object of type environment. Then instead of creating a new random position, we'll just call environment dot get random position. And we'll do the same here. Now if we save this and head into Unity, one more thing. In our get random position function, we first want to check if this position is on the ground. So to do this, let's move this on a different line. Vector 3 position equals new random vector 3. And here we'll just return the position. Here we'll do a raycast to check if this position is actually on the ground and not in the middle of the air. So we'll set the origin point to position, and we'll set the direction to vector 3 dot down, and we'll set the range to 10. Now, first thing we want to do here is make sure that this position is actually above the ground, so that when we shoot a raycast down, it won't go down into the infinite void. So we'll just set it to 5. And here we don't want to actually run any code if we do hit. We want to run code if we don't hit. So if we don't hit, we'll say position is equal to get random position. Now this may seem redundant, but what this will do is if we don't hit a position, we simply call this function again to get a new random position. If you don't have any colliders in your scene or the distance is too small, then this will create an infinite loop that may crash Unity. But this should work. And let's see if everything worked. And as you can see here, our cube's moved to a random position. But now he's not moving again. What's supposed to happen is once he gets within a distance of 1 to the position he chose, he will create a new position. But we're not getting that. So let's find out why. Okay, so after some debugging, I found the problem. When we return the position has a y value of 5. But when moving, we never move on the y-axis. And when calculating the distance, we still input that y position of 5, since we don't change the target position. So that means the distance is always going to be greater than 1, since the target position will always be above us. So here, we're just going to call new vector 3 target position dot x transform dot position dot y and target position .z. Now this should work perfectly. And as you can see, our cube is now moving around to random positions in the world. Awesome. So, what next? Well, we've got movement, so all we need is resource recon. So, what next? Well, we've got movement, so all we need is... Well, what next? Well, we've got movement, so let's implement the next step. Resource consumption. Now, resource consumption usually includes eating food and drinking water. But this is going to be simple, so we're only going to implement food. So let's just create a new cube. Let's call this one food. And we're just going to set its position over here. Let's make it a little smaller. And let's give it a nice red material. Well, so now what? Well, we need to make it so that the cube can actually detect the food. And once we implement genes, we'll use the genes for the vision radius. But we're keeping this simple for now, so we're just going to give it a vision radius. Create a new float. Call it vision radius. And here we're just going to set it equal to 30. So to get it to detect anything within this vision radius, we're going to use triggers. Now, triggers is basically like a collider, but when something goes into it, the onTriggerEnter function is called, allowing us to run all sorts of code every time something enters the trigger. So let's just put void onTriggerEnter, and here we need to detect if we found the food. So we're going to create a new script and call this live entity. On the food, we're going to attach this live entity script, and we're also going to put it on our green cube. So the way it works is when something goes in a trigger, it's going to check if that object has a live entity script attached to it. And if it does, that means it's another creature. And we can do all sorts of code based on whatever we find. We also need to check what species it is. This will be for later when we add more species. Species. And this script is actually going to be an enum. So we can just delete all of this. Public enum species. Now we need some actual species to put in here, so we'll just do green cube and red cube. Great. So now in the animal script, let's create two variables. One for the species, and one for the diet. Then, in our live entity script, we want to create a new species to check the species. So now in our animal script, in this method here, we want to check if the collider that entered our vision radius is a live entity. So if other dot try get component live entity out live entity. Basically, what this does, it tries to get the live entity component, and if it succeeds, it will give us this entity variable. Now we can check if the entity species is equal to our diet, meaning we eat whatever animals this is. And if it is, for now, we'll just set target position equal to position of the entity. But if you were to run the script now, you would find that nothing happens. And that's because we don't actually have a trigger. So to do that, in the beginning here, say object dot add component sphere collider. But we want to be able to access this in order to set it to a trigger and change the radius. So we'll say sphere collider trigger equals GameObject.addComponent sphere collider. Here we'll set the trigger dot radius equal to our vision radius, and set trigger dot is trigger equal to true. Gonna go to the food. I'm gonna set the species to red cube. I forgot one more thing. In order for untrigger enter to actually work, we need to give them both rigid bodies. But we don't actually need the physics, so just check is kinematic and uncheck use gravity. Now if you play it, it should all work. And as you can see, once he spots the cube, he goes directly toward it. But something you notice here is that when we start, he doesn't actually notice the cube. Not until he leaves and comes back. That's because we're only checking every time something new enters. So to change that, just copy this and change this to stay. So this function will be called when something stays in the trigger, meaning when he starts, he'll see the cube immediately. Also, if we have a predator chasing an animal, the target position will constantly be updated as long as the animal is within their vision radius. So save that, head back into Unity, and everything should now be working. As you can see, he continues to chase the food as much as possible. But since he can't eat it, he's just stuck forever going towards the food. Next time we'll be making it so he can actually eat the food, and so that he can die when he's too hungry. So, stay tuned.